Alright, good night everyone. I'm Chris, and thanks a lot to Alpic for inviting me today. I'm here to talk about how we implemented progressive tool calling in our app. So before I start, what is Slite? So if you don't know, Slite is a knowledge-based software. We built it as an ideal place to store team knowledge and verify it, and more we are building it as an agentic way to maintain your knowledge up to date, which we think is very important for the times to come. Now, in 2023, we were the first knowledge base, like literally in January 2023, so a month and a half after ChatGPT, we were the first knowledge base in the world to release an AI search. It had a lot of success, and that led us very soon, by listening to our customers, to build a second product, which is an add-on, which is called Super, which is an enterprise search product. So we allow you to connect all the data source of your team. We understand how it's structured. We understand how to find information, and we basically give you like the most accurate way to get company data. So that's on the tools. Today I will focus most of my talk on Super for this challenge on how we implemented progressive tool calling. Shortly on Super. So the idea is you probably played with a lot of tools left and right. You probably played with a lot of MCPs connected to Cloud, to ChatGPT, whatever. The challenge is to get accurate data. You have a lot of retrieval manners that, like in these tools, in most MCP don't, for instance, implement semantic search. It's just one of the many retrieval manners that you miss in these tools. The other thing, and really what we try to optimize for, is to get Super to be very easy to access by any teammate. So we built Super for humans. So typically this is just one example of the entry point of Super, where if you have the Chrome extension of Super, you will have Super that arrives in all your teammates' intercom or any website you decide to. And of course we have an MCP, and we designed it to be the ultimate hub for your agents to also be able to tap into all your company data, whether it's SQL database, your semantic version of your Slack, your Notion, your documents, but also structural retrieval of your GitHub data, like really anything from your team with respect of permissions. Very quickly on Super. Yeah, so this is my Super. I just launched the first query on my data, give me an update on my current project. It detected on Chris. In this case, it decided to look into Lina and GitHub. It probably did also another listing of the information that it has on me. And it started to generate the answer. The idea of Super, because we are manipulating unstructured data, we are manipulating knowledge written by humans, we really try to put at the core the ability to double check what information has been generated. So in this case, we have like inline explainer of which source has been called, with this kind of explanation on why it has been used. Yeah, you can see like some questions that I asked earlier today, typically for this demo, like was a parameter to submit the question in Super. Here I had like some BigQuery query handled in natural language. Some more funny stuff, like you can generate images and combine like GitHub with Linear, with multiple tools. And you can see here a list of tools being called one after the other. And here we are reaching to the core of the problem that we'll address in this talk, is that we have too many tools. So when we started, so we launched in May last year, we had just a few tools. We had like a Slite, which is our knowledge-based software, all these tools for semantic search mostly. And then we had like the last few ones, so semantic search and charts. So we still could generate some charts from Linear and GitHub and so on. And that was good, because like 10 tools, a few subtools for each, it's okay for your context window. And the problem, which is a good problem to have, is that we started to explode the number of sources that we manage. So we have like 20 plus native sources for each tool. We will develop like subtools. And then we start to develop more and more agent tools. So we have like a tool to read entirely a document in context, to browse a tree, to decide to grab more, to query specifically SQL database, to list code repos, all these things. And of course, with MCP it gets unbounded when we have like MCP as source that are arriving. This was the trigger point where we were like, okay, we can't continue like with the naive approach to feed tools in the system prompt. And yeah, like the tension that was already evoked right before is basically if you start to push a lot of tools upfront to the tool before asking your question, your accuracy drop, even with better models. Of course, we have a big problem of costs, and you know, it gets much lower to get your data. So it can come to two problems, like you have just too much context being fed by these two definitions. And the second one is cache invalidation, which is basically the same facet of the problem. So we'll start with the first one, the context budget. I actually run this right before in my clone, asking it like how much context have you consumed already, like just as the first question. And in average for me it's like around 10 to 15% depending on which MCP I have. So it's basically like, you know, the context window right now is like 200k tokens. Immediately like you have like a massive part of this that is consumed with not that many MCP connected. And the translation of this is that in certain core tools of the market, like key tools of the market, you already have a tool cap, like you can't add as many as you want. So yeah, we need a solution for this. And yeah, like the kind of, I think it's worth noting like the counter side of this. Like you could say, okay, let's start the conversation with just a couple tools, and then like we, you know, modify the whole prompt and just inject an additional prompt in the tool's definition in the middle. The problem is that this invalidates all the cache. The input cache costs really little, and that's the only way we can have multi-round conversations in any AI tool. And so if you change the definition of tool and you realize in terms 3 at the end that you need the chart tool, you basically invalidate all the cache and you are just double paying. So this is not a solution. And so, yeah, like we went from one solution that was a bit naive, which we call disambiguation, to a solution that is hopefully a bit less naive, which is called progressive tool coding. So that was like our first solution. So as you remember, in May, we had like maybe 10 sources. We had GitHub, Linear, like some CRM tools, Slack, Asana, and so on. And we had these little tools that we call, for instance, disambiguate GitHub. The big advantage of this one is that, as you can see, like we give it a date range to get the definition, because the schema of these databases, they change. If you have your Linear, your Jira, whatever, you might decide tomorrow to change the status level of a done ticket to over with. Problem is, like with MCP, with API calls and so on, like it means that the signature of your calls need to change. And so if you are looking for all the tickets over with of last year, it was indexed as done, and so it completely fucks the system. So this was like a smart first step. It basically returned, actually like this is maybe even a better example. It returns the assignee, so which collaborators were active in the code base at this time, at the time of your query, and which were the labels that were active at this time as well. So that's cool. The problem is we are still filling the context, because for each tool that we were developing, we needed a new disambiguation tool. And these tools started to be also quite heavy in terms of like their own definition. And then we realized that as we were facing the problem, of course, we needed to fix this problem. We had like the MCP coming up. We had like a lot of problems with a new type of source that were, that needed like this type of solution. We realized that disambiguation was actually quite close to the progressive coding that you have, for instance, when you see, this one is an example for SQL. Like you don't need to have inspect table and query table defined before you call find table. Like the only way that you can have this being in use is that you already fetched one table. So that was kind of like our insights. And so what we developed was a tree of tools, a just-in-time tool loading tree. And so the idea is to bulk some tool calling and to get some definition from them. So here, for instance, we have get, dev, and project tools. So you ask a question about like what's my current project status. You can still know that you have Git, GitHub, linear that are connected, and probably the user is asking about this. And so we'll get a form of disambiguation just for these three tools, and we'll ask for like the complementary tool from there. So this is like the way like the very basic tree looks like. So for instance, I think we'll show in the demo right after, like we have like an ability to read your code base and to browse your code base, really like a Cloud Code, like you can imagine doing so. And so for the Code Explorer, instead of loading everything up front, you can call the Code Explorer tool, get all these subtools, and call them when you need it. So yeah, this is how it can look like in practice. You have the user asking like, I need an MR chart, and I want you to look at the data that exists in a SQL database in BigQuery. We get 3 BigQuery tools definitions that are just loaded by default. We will kind of like look at find tables, so which table the user might have precised it, maybe not. Which table is accurate for this query. Then inspect table to kind of check its schema, create the table, and then once it has like received the table, it can basically dynamically inject chart tools so that it can generate the visualization of the result. This is probably like the clearest example, but this one, for instance, the chart tool, you absolutely don't need it if you don't have data. There is no way to use it if you don't have data. So you will have all this sequence that will call the tree just in time to get the right type of tool. The results for us were that we now can load only 70 tools upfront by default, and have 65 of them available on demand. With, of course, like much more if you start to connect like MCPs and other things, which is something that we're still working on, but like that unlocks us to work on it. Of course, nice benefit is that you have just less context, so it's faster and cheaper. It's not the reason for which we do it, but it's nice to have. Super is already very fast versus other solution. Okay. And so here, for instance, I have something that is connected to Slite. I told Super to look for an article in our Help Center, so you can see that it's looking for this. And then for each piece of information, it looks in our code base to see if it's still accurate or if things are missing. So here you can see that it started to this code repository. And basically, I'm not sure if we missed it already. Yeah, I think we missed it, but basically it already kind of called the tool to get the other tools to read the code base and to navigate the code base. That's a bit too fast. And now, like what it's basically doing is that for each part of the document, it's double checking all the information, and it will generate a table to tell me like which part of my Help Center article is right or wrong. This is the preview part of Super, but one that is very exciting. I think I can show you like, yeah, it's look like this. Basically, like it can like just give me like an overview of all the parts of the Help Center that are incorrect or slightly incorrect, the part that are missing. Like so, some shortcuts are not indicated. For instance, the hit color shortcut. So yeah, great. Now, this was a drastic improvement for us. It means that we can scale to basically any tool and have like something that is reasonable and that won't cost also us too much. I don't think it's an evergreen recommendation. Every time that we move and edit our engine, like we learn a lot, and 3 months after, like we have a new optimization that comes. Typically, like the next challenge that we have, that I try to kind of show it in a very bad way, is this is a question: what's our current NRR? where Super found the information. This was asked like earlier today. It found a document that looks terrific from 1 month ago with like, you know, like it has the Sons of Truth, like it's January 2026 MBR, like awesome. The point is that I have the data in a Profitwell, like BigQuery SQL database, and I wanted to use the current data. I don't want it to find it in a document. I wanted to compute, to have the real-time information. And so I asked it to look in Profitwell BigQuery. And basically the feature that we need to build next is to be able to store in memory where the data is located to accelerate, you know, like to replace this and to know that Super knows how the structure of the data internally is made, so that it knows which part of the sources to tap to get the most accurate information. That's the kind of thing that this kind of is dynamic, not tool coding, but this is dynamic memory coding, just on the kind of meta on how the structure of the information is in my team. That's also something that will improve our engine at the end. But yeah, so it just never stopped to optimize for this. And maybe one last thing, which is more product, because I'm more product, and I try to stretch a bit myself on this. I believe very strongly, especially as I'm building 2 products and 2 agents in the last, you know, like 10 years and more recently 2 years for Super, that the future of MCP, which will simplify a lot this problem, and actually it comes with it follows well the last point of the deck before me, is instead of having a lot of atomic tools that you know, maybe are a bit dumb and that give a lot of room for failure to the AI coding them, I really believe that the future is like having sub-agents that are incredible at their own dedicated job, which means that Claude or whatever will have like a few tools for your business. One which is like the linear agent, that they don't have to understand like how it works, but they will just say in linear log a bug assigned to Pierre-Louis about X, and that's it. And it will know your structure, it will know how you label things, it will know which team to use. The same for knowledge, like you're building an agent for you to be able to say, instead of manipulate a series of tools like this, just update the document with this data. We actually have like something that we are working on right now, which is a good embodiment to see it in Slack. But yeah, like that's, I think, the future, and that will lead to hopefully much less and smarter sub-agents, and that will simplify also a lot of work of other people after us. And yeah, that's it. If you are curious to follow a bit what we do, go check super.org or slide.com, and yeah, follow me on LinkedIn.